Hi everybody, thank you for joining me today as we explore projectile motion. So I have a problem for you, and if any time during the video you are inspired to try this out by yourself, if you know how to do it, feel free to stop the video and see if you are ready to take on this challenge. So the problem goes like this. A projectile is shot from the edge of a cliff, h equals 145 m, above ground level with an initial speed of v naught equals 155 meters per second at an angle of 37 degrees with the horizontal. So let me just rephrase that. So we have a projectile motion problem. The height of the cliff here is 145 meters. You can see that the projectile is launched quite a bit away from the ground. So not only does it travel upwards, it also travels downwards past its initial point, and it goes all the way down to the ground level. So this is a 1, 2, 3, 4. This is a 5-step problem. The first thing we're going to do is determine the time taken by the projectile to hit a point P at ground level. So our point P is right here. This is also point P. Okay, so the first thing I like to do when I try to do physics problems, I write down horizontal and vertical components. Because in physics problems, you can always treat horizontal and vertical components separately. That's the great thing about this. You don't have to calculate all the diagonal lengths. You can just take a length like this, you can break it up into its horizontal and vertical pieces and treat each part as separate. So I always list 6 things when it comes to projectiles. We have x, x naught, v, v naught, a, and t. Vertical, we have the same thing. X, x naught, v, v naught, a, and t. In this problem, in this case we're looking for t. So we're going to put question marks for both. And we know that the time would be the same. Horizontally and vertically, the time for this projectile to land at point P would be the exact same. So what do we know? Let's start with horizontal. Horizontal, the acceleration for any object in projectile motion, horizontal acceleration would be 0. Now, realistically, it might be slightly less than 0 because it might slow down due to air resistance. However, we want to neglect this to make the problem easier for ourselves, and the air resistance would be fairly small, so let's just pretend like there is no air resistance and there's no friction. So in that case, the acceleration horizontally would be 0 meters per second. Now vertically, the acceleration would be 9.8, which is gravity. 9.8 meters per second squared. Next, so what else are we given? We are given the height of the cliff. So what would that mean? That would mean that if this was the starting position right here, if you're looking vertically, this would be x naught. By the way, this symbol naught refers to initial. So the initial distance is right here vertically, and it ends right here on the floor. So if you're just looking at the vertical aspect of it, neglecting the horizontal motion, it goes from here down to the floor level. So this would be our change in x. This would be our final. So we know this is 145 meters. So it depends. We can choose, since we chose that acceleration is 9.8, which is positive, we know that motion downwards is in the positive direction. Therefore, x final minus x naught, which is change in x, the change in x would be positive. Change in x, x final minus, yes, would be positive. Okay, just double checking. Alright, so we have here 145 meters, that would be our final. So we can put it here, x. By the way, x final would be the same thing as x. Should be initial. X naught. X naught is 0 meters. And we can see that x is 145 meters. Let me add equal signs to all these things here. So let's finish off the vertical. The vertical velocity. Now, we know that the velocity of the projectile is 155 meters per second. However, this is neither vertical nor horizontal. It's somewhere in between. So to figure out whether it would be vertical or horizontal, we could draw a triangle here. This is 37 degrees. And this is 155 meters per second. So we're looking for the vertical and the horizontal. So this component right here and this component right here. So we can do it whichever way. So the formula for this would be, for this one would be 155 times cosine of 37. Make sure you put your degree in. Whoops. Put your calculator in degree mode. Excuse me, because I've made the mistake of putting it in radian mode, and that never helps. On this case, if I may be allowed to write diagonally here, this would be 155 times sine of 37. Alright, using my calculator, I get a value of 37. I put 37 degrees. Make sure. And the value would be 93.28 for the vertical. This would be 93.28. 93. And usually I prefer to round to the 3 decimal places. You can either round or truncate, whichever way you like doing it. So if you're rounding to 3 decimal places, you get 93.281. And for this one, and before we forget, we know this is the vertical velocity. So let's put this here under vertical. By the way, this is the initial, by the way, because you're looking at the initial velocity when the projectile just starts to be launched. So the initial velocity, vertical, as we wrote down here, 93.281. Let me write that down. So once we find this side, 155 times cosine 37 degrees, we would find the initial velocity horizontal. So as soon as I enter into my handy dandy calculator, we get a value of 123.789. And when we come back, we will finish off the problem.